15. Let's start. First of all, thank you for being here today. It's a Wednesday evening. I get that. It's really difficult to go anywhere outside, especially the late evening. I think we would have liked it to be on a Thursday evening, but that's when usually there's more traction for people to come in, right? But there was some challenges with that. So welcome to this meetup. So today, I think let me first start by introducing our sponsors here. Convergence is our sponsor for this event. So they have been kind enough to help us with this facility. They have also been kind enough to bring food out here and the required setup. So I'll let first Convergence, if you can come up on the stage, Justin, and give us your introduction, what your company does. Sure. If you want me to pull up the slides. First time any living here? No?
Thanks, guys, for everybody coming. So I'm Dustin Hughes. I manage our office here in Dallas, and my team is back there. So we've got my recruiting manager, Brian Banabi, our sales assistant, Leah Mashing, and one of our other recruiters, Rodney Brooks, in the back too. So just want to give you guys just a quick run through on Convergence. So we're actually based out of DC. We're founded in 2000. Our Dallas branch was actually opened in 2010. And I started actually in 2011, so just shortly after we opened this office here. But we actually have recruiting capabilities across the country. So as it shows, we have consultants in like 35 different states. We do mostly all staff augmentation. So contract to hire, permanent jobs. So, and then it doesn't really I guess affect us as much here in Dallas, but for our DC office, we are a facility security clearance secret, so it helps out a lot on our like government clients out in DC. We don't necessarily do as much around here, but obviously love to explore that space.
You want to talk a little bit about what is facility security clearance?
Yeah, so I guess whenever. And I'm not the expert in that, but so like if someone has a security clearance and they need someone to hold that whenever they go onto a contract role, so we're actually allowed to hold that for the length of their project, so they won't actually lose their clearance whenever they go onto the projects with us, if that makes sense. And then also I just put up there we did a study here recently, sent out a survey to all of our clients and all of our consultants, and we ended up getting Best in Staffing Award. So basically we had a 98% return on everyone come back and said that they were happy with one, either working for Convergence or working with Convergence. So it was nice for us to put on our signatures and kind of promote that as well. So and then just run through a few clients that we have here in the DFW market. So we do a lot of work with Capital One up in Plano. Fannie Mae, now in Plano, was in Addison. Neiman Marcus with these guys. And then GM Financial down in Fort Worth and in Arlington as well. BNSF Railway out in Fort Worth, and then NEC Corporation of America in Irving. And we'd love to add on to that if any of you guys are hiring as well. And if any of you guys happen to be on the job market, feel free to send us your resume. We all put our business cards in those bags in front of you guys as well, so you'll have mine, Rodney's, and Brian's as well. So if any of you guys are looking for a job or know anyone that is, feel free to shoot us an email with your resume and all that. Here's just a few of our active roles that we have open. So anywhere from, a lot of AWS here recently. We just actually got another machine learning engineer role in Plano today, actually. So we're going to have to update the slides. So, and then as I mentioned, if you or your colleagues or anybody is actually hiring and needs some help, needs some support, not getting what you need, feel free to reach out to us, and we'd love to help you guys. As I mentioned, we do a lot of contract to hire roles, but if we need to do permanent placements, we can obviously do that as well. And I'd love to meet you guys one-on-one afterwards if anything that apply. But other than that, thank you guys for coming. Enjoy the food, drinks. Enjoy.
Yeah, I think convergence is awesome. We definitely work with that closely. And thanks for helping us with everything here. Thank you.
Absolutely. Thanks.
So before we kind of dive into, like, I was just trying to get a pulse, a pulse of your experience, exposure in machine learning space. So anyone who has had experience in pushing workloads of machine learning implementation into production? You do? That's nice. Okay, so it looks like pretty much most of you are new to machine learning. Okay, so we did a poll online as well, trying to understand who will be our audience and what should be our content, right? So our content is kind of tailored to beginners in machine learning space. So do you have a question?
Yeah, I kind of jumped onto your meetup and showed up here, but what's the agenda?
Yeah, we'll talk about it, which is what I'll get into right now. First of all, let me introduce myself briefly. So I'm Lijesh Shetty. I've been working in machine learning space for the last 2 to 3 years now. So we are from Neiman Marcus. So we work with Neiman Marcus. I'm sure you know Neiman Marcus, luxury retailer. We sell luxury items. So I'm part of the data science and machine learning group at Neiman. So where we are in Neiman today is, like I said, we started machine learning like 2-3 years back. Now we are at a point where we want to take it at a much bigger scale, right? So that's where we are with machine learning implementation at Neiman. I think so. The reason for setting up this meetup group, right? So one of the realizations which we had, over the past 2 to 3 years is, in the machine learning space, looks like there's a dearth of, resource or dearth of skills, a lack of people who are really into machine learning space, and there are plenty of opportunities in that space, right? And what we really wanted to do, or what we want to do with this forum, is essentially, to have a. Sorry, looks like I was blocking the screen. I'll go on this side. What we want to do with this meetup group is build a community here in the DFW metroplex, right? Essentially, machine learning community where we can all come together, talk about use cases. Right. We'll talk about use cases and talk about how we go about solving those use cases, how we build ML models to address those use cases.
So there are actually a couple of meetups on AI machine learning. Also, there's one I think just specifically for deep learning and image classification and of that sort. But I'd be very interested to know where you're going with this.
Sure, absolutely. So I think the machine learning space, I'm sure there are more meetups and more meetups will come. So I want to say at the outset what we are not, right? What we are not is, we are not a training forum. We're not going to train people on machine learning skills. That's not the intent. The intent, like I said, is to have this forum where we can talk about use cases, real world problems, and talk about how to approach building machine models. Right? That's the intent. As part of our forum, we also think what we'll be doing over our next set of meetings over the course of time is we will invite leaders of the industry. We will invite the people who have had experience in machine learning implementation. We'll invite them to come up here, talk about their challenges, talk about their use cases, and walk us through how did they overcome those use cases. Does that answer your question?
Yeah, it helps.
Okay. The other thing I think what we wanted to do as part of this discussion is, I think there is a lot of myth around machine learning, right? There's, to a certain extent, people are scared of getting into machine learning, right? We want to kind of break that myth a little. We want to, with our presentation today, and hopefully, you'll discover that machine learning is not as difficult as you would have thought about it. At least that was the case with me. So we want to break that myth, right? So depending on your appetite, depending on the level of expertise you want to get into, right, there is ample opportunity within the machine learning area for you to gain your skill set, still be effective, still be good at building models. So part of it we'll talk in today's session. I think as far as who is, so we are a group of 3 right now. At least this meeting organization was done by a group of 3. So I have my colleagues from Lehman.
I am
Rajendra Jonnadula and Krishna Mishra. So we'll basically walk you through the presentation. And feel free to ask questions if there are certain questions you want to ask. Let's talk about it. We want it to be a much more vibrant discussion rather than one-way monologue presentation. With that, I'll kind of give it to you, Raj.
Sure. Thank you. So, it looks like most of you are aware of the word machine learning. Some of you have experience. That's good to know. Hi, welcome. So, how many of you really know what is machine learning? I don't want to put you on spot, but feel free.
Yeah, what you just did. Yeah, when you say like really know, that makes me doubtful of my answers. But I mean, it's basically like training training a machine to sort of recognize patterns and kind of take some action based on that.
Okay. Over to you. Any ideas?
So what I learned in my school is just you choose, you have some problem and then you want to deal with it with data. So you just choose an algorithm and then put the data set into it,
yeah.
And then you get your model and you use this model to forecast or find out something like clustering or prediction, something like that. Yeah.
Awesome. You wanted to say something? Okay. Yeah, that's almost like we all know that there is a lot of data and you can train and then you can then use that model to actually predict what's going to happen or what your model is now trying to predict. So let's take some very simple basic examples of how this all can be accomplished and see if it all makes any sense. So, you know, you are given a task to actually write a program to identify two fruits. How would you do it? You know, you would try to think about colors. You know, for example, like here we put apple and orange. You can say that apple is red, orange is orange. So maybe by picking a color within the pixel, yeah, you know, I think I can predict that it is an apple or it is an orange. That's how we generally think, right? So we write that program, we think that, yeah, I got my program done. Now I know when an apple shows up or when an orange shows up. What if you are given a grayscale? How would you then use your program?
Only the shape.
Okay, that's a good answer. Anything else? Shape, certainly, right? You know, but
Weight. Then probably weight, another parameter.
yeah, but you know, programmatically you may not know the weight.
Yeah, what are our inputs here? We do images that we're trying to
Yeah,
classify?
you're just given 2 images.
Okay.
All right. Yeah, so that means you're just going to be like limited to, you know, the pixel data. So I mean, you can, I guess, like run a kernel or like look for, you know, certain like textures or, you know.
Right. Yeah. So we know that by color we can distinguish, but with grayscale we need to now tweak the program to actually add more parameters to it to identify the fruits. Now what if we are given 2 similarly looking colored pictures? Once again, the shape and size may all be the same, and still our program cannot really identify, because we are only given so much of information, and based on the information we are trying to code the program. So we are actually depending on our basic knowledge of what we want to achieve, and then we are trying to write the program. The machine learning process is completely reversed. That's how we are doing it. So what is machine learning? So how can machine learning help us to solve this problem? So basically, historically what we have been doing is, you know, computers have been designed to do jobs. More, whatever humans can do, computers have been doing it in a mass scale, all this way. And by doing so, they are becoming faster. They have, you know, a lot of advancement happened in the computer industry that it was able to do so much of workloads at a very enormous speed. And that's how we've been doing it so far. But the pendulum has changed. You know, we now got so much of data, we have a lot of processing power at our disposal that we are now able to do a lot more things. And the way we are trying to now do it is add more data, identify the patterns within the data, and then understand the data, create a model out of it, and then go and attack the problem with all the knowledge that you have gained from the data. That's what is machine learning. So machine learning, in essence, is a study that gives computers the capability to learn without being explicitly programmed. So you cannot really keep on making changes to your program as new data arrives. So what we have done is give the data, and then the model automatically learns, and then once the model learns, it will now take the additional data, and then it keeps learning, so it becomes a vicious circle for it to continuously learn and then move forward. So many of you may think that machine learning is new, it's a new concept that came into being, but actually not. It is there, right, I mean, way back from 1959, but a lot of research happened in the 70s and 80s, but then they lacked so much of data. Today we have the advantage of a lot of data at our disposal, and that's why we are now in a position to actually use the data and then start making the predictions. So for us to actually capitalize on machine learning, we need 3 components. One is data. The second one is the processing capability, which we just now spoke, that, you know, we have a lot of processing capability at our disposal. The third one is mathematics. Mathematics have been there for ever since. But the algorithms that have been there, and then the complex algorithms that were there forever, we now have the processing power to actually use the ingest the algorithm and then run the data and now create an output. So these are the three basic components of machine learning. Any questions?
Yes, I have a question.
Yeah.
From your experience, what are the limitations of machine learning?
So limitations in the sense, these are your inputs and these can be your limitations as well. So for example, if you have very limited data, your algorithm or your model may not truly get what you are looking for.
Yeah, the scale of data which you have, that's the limitation. More the data, better it is, and data itself, right? So what you feed into model is what you get out, right? So how relevant that data is to the outcome, to the target, right, is very important. So a large part of, I think, machine learning problem is around feature engineering, which is essentially trying to understand what your data is about, how are they related to each other, right, and how does it impact the target, right? So it's, yeah.
So if I may add to that, I think
Sure.
biggest limitation probably from the clinical side would be the quality of data. And as you start working on a problem, you realize that a lot of your time, I want to say, and please feel free to disagree, 50 to maybe even 80% of your time is spent actually cleaning up and
Yeah, I
sure
think
that the
what
data is good for the model that you're trying to feed it. And then feature engineering and all comes out later. But primarily, just trying to go through the data, and you have a good training set. So basically, it's a training set. You have data that you train it with, you test it, and then you validate. Right? So this part here, we have the right set. Everything is
Yeah,
a
I
big
think what
part
we will
of
do is in the subsequent slide we have the steps of, we have listed out the steps of training a model or building a model. Some of which we just talked about, we'll talk about it. Right? So he is right, there are other challenges as well as you build a model. Right? Yeah, we'll get into this.
Yeah, let's get more hands into machine learning and get us that pretty clear. Okay? On
Thank
to
you.
Lijesh.
Thank you. I think the key takeaway from what Raj was explaining is this, right? Before machine learning, the way we would program is we would, basically write rules, right? Data is fed into the system, we write rules, and based on the rules, we decide on the outcome. What machine learning has done is now you don't have to write rules, right? You feed data and you feed outcome, right? And the model now predicts, kind of rule, right? What rule it is applying. So that's the fundamental shift when you think about machine learning. So let's talk briefly. Like I said, in this presentation we are going to stay, the high level, right? We'll cover broad areas. We'll try to cover, the scope of what machine learning is at a high level. So if you think about types of ML, right? So machine learning model itself can be categorized using different ways. There are different ways to categorize. One of the common way machine learning model is categorized is using the learning mechanism. So how is your model learning? Right? So there are three ways. It can be a supervised learning model, it can be unsupervised, or it can be reinforced. That's fourth one, which is semi-supervised, which I'm not going to talk about today. Right? So let's talk about what supervised learning is all about. Does anyone know what supervised learning model is all about? You seem to be familiar with machine learning.
Yeah, under like a supervised learning model, then you'll have like your training set, right? And you'll have like kind of like the answers to all of these that like to train it on, to say like, yes, this is this other thing. And so someone's basically by giving a lot of examples, training the algorithm.
Awesome. Go ahead.
Can you give a specific use case for supervised learning?
Yeah.
For example, predicting a price of a house or predicting the best move in a chess game?
Yeah, I'll talk through it. Go ahead.
You have dependent variable. Just you want to predict something, so you know the answer, the variable. Yeah. So let's supervise it. Am I right?
Yeah, pretty close, pretty close. So supervised learning, as the name suggests, right? What you're doing essentially is you're giving all the inputs to the model, and you're also giving the outcome which the model should be, predicting on, right? So what model is doing now is model's got the input data, all the input features, and it also has now the outcome. So it builds a mapping between the input data to the outcome, right? So that's what supervised model is about. So if you think about, right, that's a good use case which you brought up, the house price, right? So if you think about house price, right? So if I were to build a model for house price, then just keep it simple, right? If you think the house price is being affected by the lot area, maybe number of bedrooms, maybe neighborhood, right?
So you can use zip code, you can use square feet.
Yeah. So you may have a list of features, right, or list of inputs, right, and you provide that to the model, and you also along with it provide what is the price of for each mapping or correlation, right? So that goes as an input to the model, right? So that's what supervised model is all about, when you provide both the input features as well as the target outcome, right? Slight variation in this is there are two kind of models. One which we say as the continuous output. In other words, if you think about a house price, right? As any of those features change, the house price changes, right? But it's a quantity, right? It's a number. On the other hand, like the example which Raj was talking about, which is identify whether it's an apple or an orange, right? This is a discrete output, right? It's either an apple or an orange. So this kind of models are called classification models, right? So anyways, when we come to supervised model, key thing to remember in supervised model is we give it input data, we give it the outcome when we train the model. Now, when you think about unsupervised model, right, it's pretty clear that unlike supervised, it's trained differently, right? And in case of unsupervised model, the difference essentially is you provided the data, you don't provide what outcome you're looking at, right? So have you used any unsupervised model, or do you know what a typical, what would be a good use case for an unsupervised model? Segmentation. Right, that's a good example. So one of the things which we had used in Marcus, for unsupervised is we had analyzed our sales data using the unsupervised model, which is through all the sales data, and what unsupervised does is it basically builds different clusters of behaviors, right? So from that we were able to glean some important information. What we learned, one of the learning was apparently the younger females shop with demon markers more frequently during the week, compared to older females. Also for actions which are positive, it gets rewarded, so it knows that this action would be preferred. Whereas for the actions where it gets penalized, it remembers that to avoid those actions. So those are three common machine learning models: supervised, unsupervised, and reinforced learning. What I will quickly get into, I think that gentleman was talking about, is what are the different steps which you have to go through in a typical machine learning solution. So there are, at a high level, there are 7 steps. So I'll briefly talk about it, and feel free to ask questions. I think in interest of time, I'm going to move a little fast, right? So the first step is data gathering, right? Once you know about the problem, usually what we do is, we reach out to a business has a potential use case which they want to solve, right? Which they want to get some insight into. We work closely with business, understanding what their requirement is, and then we kind of go back to our data warehousing and understand what are the data points we already have in our data warehousing system, right? And we gather data based on our discussion from, with the business, with what we have and what we want to, develop, right? Feel free to stop me. Like I said, I'll go a little fast. The next step is data prep. So once you have the data, data, now you load data in a suitable place, right? And then what you typically do is try to understand your data, right? Try to look at the different fields, different inputs, and see how do they correlate back to the outcome, right? So you go through that process. One of the important thing in data prep is, as you prepare the data, typically what we do is we break the data set into 2 portions: training set and validation set, right? Training set is the data set with which you will train the model, and validation set is the set which you use to verify whether your model is predicting reasonably well, right? So you basically break your data set at least into 2 different buckets, and typically what we do is training set is usually 70 to 80%, and the remaining is validation. And in case of Neiman, we break it into 3 sets. We have validation as well as we have something called test set. But any case, that's completely your choice. But it's recommended that you break your data into multiple sets. I think so let me skip those. Like I said, if you have any questions, feel free to ask, and I can definitely talk about it more. The next step is choosing a model, right? So once you know what data set you have, what problem you want to solve, there are a list of models which you can use, right? So like I was talking about earlier, if it is a continuous problem which you want to solve, you're probably looking at a different set of model than versus a problem where you want to identify between 2 sets, right? Like if you want to identify between apple and orange, it's a classification problem, then you are looking at a different set of models, right? So it's important that you choose model, and I'll say this. Now with the techniques in machine learning, you necessarily don't have to choose one specific model. You can, there are ways where you can run or train multiple models together, and get the best, get the model which gives you the best result. So there are ways to do it as well. So any questions so far? Okay. So once you train the model, the next step is, once you choose the model, the next step is training the model, right? So what is training the model? Now, in data prep, you have prepared a training set, right? So you now give that training data to your model, right, for it to build that algorithm or the mapping. Now, think about it like the first time you learned to drive a bike, right? What happened when you first, caught up on the bike and tried to ride, right? You were not successful, you couldn't probably ride. I don't know about you, but I know that I definitely fell quite a few times, right? So similarly, the model is no different, right? So when you give it training data, training set, initially the model output, would be really off base, right? So how do you train your model? You run multiple iterations of the model, multiple times, and the model slowly learns, and there are certain mathematical functions which it runs, which I'm not going to talk about it, right? So it slowly adjusts itself and reaches to a point which is best fit. So that's how model trains itself, right? So training of the model takes bulk of the time, right, and a lot of processing capability. I think that's where the cloud processing capability, AWS, Google, they have a lot to offer today, now. They come very useful as far as training the models. The step after that, as you would imagine, once you have a trained model, you know that model is giving you a good output. Now you have also verified that around 80% of the time for your training model, it is predicting the right outcomes. Right? Let me say 90% of the time it is predicting the right outcome. Right? Now, you don't know whether the model will do it for any external data, right? So how do you validate it? So like I was talking about earlier, you create multiple sets of data. Now you feed in a second set, a different set, which is called validation set. And you run the model and see whether the accuracy is similar to what you have got for the training model, right? Training set. So if you find that for your validation set, the accuracy is say 60%, right? So now you know that your model is overfitting to training data, right? Which means now you need to go back and adjust certain parameters or fine-tune your model so that it works well for validation set and for other sets as well, right? So evaluation is that. So as far as tuning is concerned, so I'm not going to step into it much, the tuning space. But tuning, essentially, you think about it, there are certain hyperparameters which you will tune to make your model, I should say intelligent, but that's a word which is coming in my mind, more precise. So there are certain hyperparameters which you use, one of which is how many times you should iterate. Like I was saying earlier, model iterates, right? It goes over and over and over again. Do you want it to iterate for 10,000 times, or do you want it to iterate for 100,000 times, right? So that's one of the hyperparameters you can adjust. Another is, with every step it takes, how much of learning it really needs to do. So, it's called learning rate. You can adjust that, so, model adjusts based on the learning rate. Again, those are hyperparameters which you can use to tune your model. So once you've gone through this step, although it sounds much more simpler and easier, right? It takes quite some time to go through all of the steps. But once you've done all of those, you are at a point where now your model is well trained. You're good for its biases and variances. You're good for its accuracy rate. Right now, you put it into production and use it for your prediction. Right. So those are the typical steps which you do for machine learning models. And go ahead.
sorry to interrupt. This sounds a lot like genetic algorithms. How do they relate genetic algorithms with machine learning?
So in what sense? Can you expand on that?
Yeah, because you know genetic algorithms.
Genetic algorithms.
They
Sorry.
have what they call the
DNA.
iterations. In this case, sounds like the iteration, the tuning, and then you make a couple of changes in the genes.
Right.
So you iterate again, and then you make another changes, and if you have a random factor, let's say a mutation.
Yeah.
Is this similar to that?
Oh, absolutely. I think a
Yeah.
lot of concepts of genetic engineering is brought into machine learning.
Okay.
So
Yeah,
in fact, if you think about neural layers.
Yeah, neural networks is also.
Yeah, that comes from genetic engineering concept. That's good call. So do you have a background in genetic engineering? Oh, you do? Oh, nice.
I mean algorithms in general.
Okay. Probably I need to talk to you after. So that's okay. I think Krishna will take it on. So we'll briefly talk about what it really takes for becoming a machine learning professional. So one thing I briefly touched base earlier is the machine learning space, depending on your appetite, you have areas for it. So if you are really good in linear algebra, right, like I like to say, if you are really concentrated on linear algebra during your high school, then there is a lot of depth you can get into, right? But if you are like me, where when calculus class was happening, you probably didn't pay attention, then there is scope for you too. Right, the machine learning has got to a space where a lot of complex mathematics has been abstracted by APIs, by libraries, which are very simple to use. Right, so you don't really need to know how the model is built. All you need to know is how should I use this library, right? And to make things simpler, what has happened over the recent years is some of these big players in the market, like Google, like AWS, they have brought their own platforms, which has made it even more simple. So I'll give it to Krishna from here.
So usually what happens, the data science people, the data scientists, they are statistic people. They talk about SAS, they come from that world, they try to draw correlation in data and try to understand what the data is, and they try to fit business need. And they go from language like R, SAS, and MATLAB, and all those. Most of the people right now in the industry, they come from software engineering. So like most, they are familiar with Python. So there's a big gap, right? So the person who thinks the statistic is the machine learning, and the person who thinks that running model is all about computers, right? Neural network and all the logic and CPU, how we combine them together. So in recent, not recent, it's been there for a while. So there's two languages you have to know. The basic, they have very good support from open source community. If you see the contribution and the number of commits, it's very high. And they are, I think they are top languages to use right now. Julia is coming another one with the Python, but that's again built on Python. So Python and R, this is brief history about how they evolved. So like R, it evolved mostly towards statistics and data visualization and how you map data, how you see your data, that perspective. And Python is general language, it's used for everything. Nowadays, everything, even building cloud infrastructure, to writing code server side, even to do the web application and server side rendering both. So these are some of the libraries that are very, this is not very exhaustive list. I mean, there are so many libraries right now, you cannot keep track of it. In both R versus Python both, and there is no clear winner. But if your project demands that you have to present a lot of visualizations and everything else, you use R. If you have to start from the software developer perspective, you don't want to get into that, then you start with the Python. So this is the screenshot of how R Studio looks. It's a very simple program. You have to install R. Then you have to install R Studio on your desktop. And a lot of AWS, GCP, all these big cloud providers, they also have environment for you to run this. This is Jupyter Notebook. This is similar to R.
Does anyone use or have used RStudio and or Jupyter?
Okay. Jupyter. So I don't have to talk about it anyway.
So did you guys try it on AWS?
Did you try it on SageMaker?
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 Yeah.
I don't know that one.
So so I'm on AWS, so I'll talk about SageMaker. So SageMaker is a service that offered by AWS. What they have instance, EC2 instance already pre-configured with all the Python library and all other libraries what we need, like Anaconda and Pandas. And it also runs mostly in, have support for not just those, even Keras and other frameworks too. So what you do, you just go to the SageMaker, you create a notebook, you have your environment ready. You don't have to worry about Python version 2, Python version 3, all dependent library, install, server, and then you have one place to work on, right? So sometimes you work in office, that's a laptop or desktop. You come to home, you have your own desktop or laptop, and then switching the environment is really. And then next part is like once you write your code, right? You debug your code, you see your output, you visualize your data. After doing that, you have to run those models with the bigger data. So you need a bigger instance. How are you going to connect to a bigger instance? So that type you call SageMaker function, and then you can spin a bigger instance like M4 large, M5 large. It's like 16 core processors, 32 core processors, and those hardwares are really optimized for machine learning. So you get right now like Google have their proprietary hardware, this accelerated hardware, so they call it TPU. We'll move on there. So apart from just SageMaker is like ML service where you can run your Jupyter Notebook with all other frameworks what we just talked about, Keras, Theon, and Anaconda, Pandas, and all other frameworks. They have these APIs. What they're pre-built models. You don't have to build the model at all. What you do, so if you see the if I just start with a recommendation or forecast, right? So in forecast, right, you need a forecast like sales data, what the sales will be probably next month or next year, right? You can use their forecast API. You have to feed your data and you have to feed your input. Model is already pre-built. Definitely will not as good as what you think or the custom built model, because this is the Amazon model. The Amazon think how the sales happens based on your parameters. Right? And SageMaker, it gives another functionality that after you deploy your model, you can hyper-tune it to their console itself. Now, so if we go on the personalized, there's another API. So a customer recommendation that you bought one product, you will buy another product, so they will recommend that product, personalized experience, that's what they give. So most of these APIs, they are not very popular or not used in the industry. Currently one used is, these are released in the last reinvent, so like December. So they are not very popular from industry-wide, but they will, I believe most of people will be working on it. Then they have Amazon Poly. It's like if you give a text document, it will read it out as a human voice. Lex, we already know. It's like conversational agent, but in the chat bot. The translate, it's also translate from multiple languages from one to another. Transcribe, speech to text, and that's a translate, it reads the text. So, and they also have deep learning, I mean, the deep learning in these slides. So they have this eraser, right, a toy, and you build your model, feed that model to that device. It's just like a auto driving car, like small tiny car. They came up with, so you can train your model, understand how the sensor are behaving, what models you have to play. So that's from the AWS. So what advantage we get when we use cloud is like unlimited resource and disposable build environment. So you build it, you don't like it, throw it, build another one, use it. Save your, so what happens in AWS, you build your model, you save it to S3. You store in a bucket, so you don't have to worry about what happens to your model or what happens to your data. You don't even have to run your GPU or machine. You can delete the machine, so you're not paying for it. That's the advantage it gives. Like all the resources, at this scale at your disposal. And you don't have to, so with the deep learning, I'll talk about Google, they have AutoML something, that's even better.
Yeah, I think jumped in there. So one of the changes which has happened for us is, like I was saying, we were in operation for last 3 years. So we had our own form of, we still have our own form of GPU service. So because of this model from AWS, now we are moving to cloud for all of our systems. So that's a significant benefit. Managing it internally versus letting someone else manage takes a lot of work out of us.
In the Google, so Google is another big player. I think they are the best, according to me. So like Alexa versus Google Home, who wins? Not about the connectivity interface, but Alexa will not get my accent, but Google will get it. So that's how I know it's understand better what I speak. It's what you say, and they have more language support too. And the data amount of data Google had, I believe nobody has it, right? So, and their hardware is also very different, and they are pioneer in all building models. They have a lot of open source code, open source library, and they have most of the data science is hired by Google, or they work at the Google. So this APIs, right? Even as the name suggests, their name is more like what they do rather than what Amazon name suggests. The Vision API, you just feed the image, it will tell you what kind of image it is. It will have some context about the image. Same thing, cloud natural language processing will tell what sentiments, what the entity is talking about, what other thing is talking about. So APIs, mostly APIs is not even popular from Google, so they are deprecating most of the APIs, and some of them alpha and betas. From now the platform, like SageMaker, they have a cloud data lab and collaboratory. So what they have is Jupyter notebook in the cloud. You do whatever you want to do, and you can run your models wherever you want to do. And apart from that, they have AutoML. So advantage of AutoML is, right, you just feed your data, and you don't have to worry about models, what models you want to run. You don't have to worry about pruning the data, you don't have to worry about figuring out relation of the data, you don't have to see how many outliers are, you don't have to even oversample, undersample, you don't have to draw correlation, you don't even have to do anything with the data. You give them data and they will do for you, everything. They will do all the feature engineering for you. They will figure out what are outliers, they will remove that from the data, they will prune the tree, it's not making any effect on the outcome. And apart from that, so right now they have these 3 services. Most of them in beta, not in alpha. Beta means they will release in production soon. Vision, so if you put an image, they will definitely tell what type of image it without, but here you have to give your own data in this case to make that model work. So if you have like, suppose you have a company like Facebook definitely have their own product, not talking about like Facebook, consider. They have like billion profile pictures. If they feed the profile pictures, it will build a model for them. And then if they feed another guy picture, they will tell you what he's doing or what sentiment is, what the background is, what other relations and everything is, right? They have the translation, you already know, Google Translation. But again, based on your language, your input, your data, they will build the model and they will help you to expose that as an API. And natural language is natural language. So if you give it text, figure out everything what it is, or you speak, it figures out what it is. So IBM, I'm not covering IBM. I'm not very familiar with any IBM product. IBM Watson in the market, I have seen API. You also have seen the Jeopardy game, right, on the TV. It's also good. There's no, but we are only covering this AWS. And Azure. And Azure is another player from Microsoft. Microsoft, if you are using 365, you will see some of the machine learning tools that will say who recently you chatted, what you chatted, who you talk to. So if you go to the who application of that, you will see all those features coming out of the product. So all this machine learning will be soon be part of all the products we use.
So which player do you recommend? Do you recommend that Microsoft, Google, or Amazon?
This is use case. If your data is in AWS, you don't want. But again, if you think like you don't have scientists to run the models and prune the do and everything, all go to Google for AutoML, but again, they have only vision and video. So you cannot, so it's again, depends on the use case and where your data is and what you're trying to achieve with the data.
So who is, how about the cost wise? Who is expensive versus?
So it's very tedious to
Yeah, I think from cost perspective it is also subjective. So depending on how you talk to them, how you write the contract. So there is no set standard that Amazon is costlier or Google is costlier. There are pros and cons on both sides. Google has a lot of our personal data that we don't even know that they have it. So yeah, so you give an Apple image, they say that you have eaten this apple 100 times and whatnot. So there is additional context that they have that they can relate to. Versus Google may have your purchasing data, which gives another dimension of the kind of person you are.
Yeah, that's okay. There are a variety of factors which will kind of go into it, like Krishna was saying, one of which is data, which platform you are in. And for us, really, we have not yet completely explored. Because like I was saying, we were primarily on-prem, we used to run our own GPU servers. We recently moved over to AWS because that's where bulk of data is. So to honestly answer your question, anyways, any other questions? Okay. So let me say this, thanks again, thanks for showing up here today. And I do realize on a Wednesday it's really difficult to come out for a meetup, especially when you have to go into work the next day. Right? Thanks for being here. So as a follow-up, like right in the outset, I said our focus is not going to be on training part of machine learning. We're not going to spend too much of time on machine. Rather, what we would do is focus on use case, work through how to build simple models and get it to predictive, right? And as we go, hopefully we'll get into more complex stuff, right? So you should see more action coming from us. Yeah.
So do you have a plan for the next one? What's going to go out?
What I'm thinking, so at this point, given we are thinking to have these sessions once a month, at least, right? And one of the thought processes will probably push out, the use case itself, saying this is the use case which we are going to do. If you have time, if you are interested, this is the data set where you can go in and we want to predict this outcome, how do you do it, right? So that will give you time to go and practice, try to build a model and then come in, so that becomes much more interactive session. That's how we are thinking about it, but at the same token, we were expecting a lot of people to show up here today. Right? So it all depends on the kind of interest we're getting in the market, but that's how we are thinking. So what you should expect is, you should expect a communication from us. Meetup, as we schedule the next event, we are going to push out this information out there.
So again, this is our first attempt to actually have this. So any suggestion, feedback is certainly appreciated.
Good luck.
If you think that we have to do it in a different fashion, we are open to it. As Lijesh said earlier, we want to make it more interactive, more so that we build the community. It's not that you come in and then learn something or you don't learn something. It's just that we're all in the game. We want to,
Yeah, I think I will stress that enough. The intent is because there are a lot of training areas, right? And there are a lot of training materials on YouTube too, right? YouTube, online, there's plenty of training materials, right? That is why we don't want to spend time training. We would rather talk about useful use cases. And like I said in the beginning, we would also want to invite leaders. Chance for even Marcus leaders to come here, talk about the models, and how it has been used to, either improve their top line or bottom line, right? And present those kind of cases. So that's the thought process. So it's not right. Anyways,
learning is not that difficult because people have made this. You have to know all these regressions and differential equation, and you should be able to correlate the data, find the outlier, draw the graph, are able to visualize all the data. I think that's out of the, that will become very easy.